Welcome back to the video lecture series on embedded systems. This is lecture number 8. In the previous lecture, I have discussed about special registers, that is APSR, right? That is program status register, then interrupt mask registers, and as well as control register. So we have seen in brief how they are used in each case. So in this lecture, I will be covering exceptions and interrupts. So, exception and interrupts. Exceptions and interrupts are like unexpected events which will or which can change the normal flow of execution of the entire program or of a certain instruction, okay, which is currently being executed. So, if you want to know properly the difference between exception and interrupt, an exception is like an unexpected event from within the processor, okay. So while some application is running, if processor itself detects some issues with that application, so then such things are called as exceptions. Okay, say for example, if you are installing some software, okay, if that software requires certain specification, something like 2 GB of RAM, 4 GB of RAM, like that, okay. But if your system is not is up to that specification, so while installing that software itself, the processor will indicate you regarding this condition. That is called as something like exception. That is exceptional error. Okay, the errors which are allowed to take place. Error in the sense certain events which are allowed to take place. Then interrupt is like an unexpected event from outside the process. Okay, that is like a sensor action or actuator signal for which the processor has to take the required user defined actions. Okay, but how the processor should respond whenever an exception or interrupt occurs? Okay, so it may depend on the hardware or a software. Okay, then if you consider some exception, uh, something like the following activities may happen. So that is temporarily stopping a process. That is, we call it as killing a process. Say normally we see something like while opening some PDF file, for example, if you have opened it, but after certain time, if it starts to behave abnormally, so it will show you the thing that the application you are running is not responding. So in such case, you can either close the system or means close the process, sorry, not the system, and restart it. Okay, if you have come across such condition, you will be familiar to this. So something like popping out some error message, just now what I told about an application, then communicating with an external device. So these are certain actions which are involved. Then continuing the same, the instructions responsible for these kind of action, they will be present inside the operating system kernel only, and the code that perform this action is called as interrupt handler code. Okay, now we can think of handler code as an operating system subroutine. Means operating system is the platform for providing uh, providing the users to run certain applications, but at the same time the operating system is also responsible for monitoring the behavior of those applications. Are they compatible to run on that kernel or no? If any error occurs, so then in such cases what happens is these kind of uh, pop-ups will be generated by the operating system. Okay, so it may be possible to continue the execution after the instruction where the execution or interrupt has occurred. So that is the mean. So if you consider closely exception and interrupt handling, how they are handled. So if you consider either an exception or interrupt has occurred, then the current execution transition takes place from user mode to kernel mode. So user will not have any control over the currently running task. Okay. When this happens, the exception or interrupt is handled. So if you take in detail, the following steps are required to be considered for taking or for handling the exception or interrupts, okay, while entering into the kernel level from the operating system level. So what happens is, now currently the operating system will be running something, so that address or that status will be stored on the CPU register. Okay, so after addressing the kernel or servicing that what you say, the exception or interrupt, it can come back and it can also return to the main program. So along with that, it will be able to determine the cause of exception and as well as interrupt, and so that it can handle the exception and interrupt properly. Okay, so while doing that, when the exception or interrupt have been handled, the kernel performs the following steps. First one is to select a process to restore and resume. Okay, the very classic example for this is, say nowadays, like Office 365 or Office 2019 or any other uh, program running on Windows 10. Say for example, if unknowingly if your battery level is very low and if you have saved some data just before the system is turned off due to the low level battery. So when you restart the program, it will ask you to either start from the beginning or from the last previous saved state. So this is possible in Cortex M3 because of the SRAM. So SRAM holds the actual data which is saved recently before uh, the processor has been stopped in an irregular manner. Okay, so it can restore the context of the selected process and resume the execution of the selected process. Say for example, PowerPoint, if you have saved certain 4 lines of points, and while typing the fifth line, fifth point, if power problem occurs, once you restart your system, if you have saved at third point, so you can go back to that slide and you can proceed further. So at any point in the time, the values of the all the registers in the CPU defines the context of the CPU. Another name of the CPU context is CPU state. So in Cortex M3, we have from a how many exception number 1 to 255. Totally 255 exceptions are there, and how they are executed. So all exceptions cannot be allowed directly. So there are certain priority levels. So first three are having the priority named as highest to the lowest. That is, -3 is the highest priority, -2 is the next highest priority, -1 is the least priority or the last priority. Say for example, reset is an exception type. So what is its function? It will reset the entire Cortex M3, okay, or the processor. Okay, so whenever I use the term processor, always remember that it is for Cortex M3. So when it can happen, suppose if you are not able to shut down the system, or if the mobile gets hangs up, such conditions In such condition there will be a reset button, or if you press the power button continuously, so in the mobile, so it goes for reset option. Similarly for Cortex M3 also, on the board we have certain reset options, okay, which you can understand in the lab. Okay, so non-maskable interrupts we have seen already. Non-maskable means the interrupts which cannot be stopped. Then hard faults, all classes of faults when the corresponding fault handler cannot be activated because it is currently disabled or masked by the exception masking. It depends on the value of that either base pre-register or pre-mask and fault mask value. Okay, but whereas the priority levels of all other remaining exceptions are settable, you can set the priority level, that is memory management, bus fault, usage fault, SVC. So like that. Okay, we have interrupt request, system tick, interrupt request. There are 240 interrupts which can be handled. IRQ, that means interrupt request. So these are the certain exceptions which are allowed in the Cortex M3 processor. Then each what do you say, the exception will be having certain address. So how the processor should come to know that you are asking it to reset. So if I want to reset, so then it corresponds to where now? It corresponds to the offset address as 0x04, and its exception type is 1, that is exception number is 1. Okay, so you can check out here, each exception type is having the different address. 0x04 refers to what? The reset exception. Similarly, non-maskable is having the different exception, and in each case we can see there is a difference of 4. Okay, this is how it is allocated for totally 1 to 255 exceptions. Okay, so starting value of the MSP, it is not exception, it is the default value. Okay, so that's all we have in the case of exception and interrupts. Thank you.